Hey there everyone, welcome back. So I assume that you guys might have already figured out what we are going to discuss in this video. And yes, you're right. We are going to discuss your chapter number 8, that is trigonometry. Its key aspects and everything that you need to master this chapter. This video is going to be really interesting and beneficial to all you guys. So without a further ado, let's get started. So starting with what is trigonometry? So trigonometry is comprised of three different words, that is tri, gon and metry, where tri means three, gon means sides and metry means measurement. So from here we understand that it is a three-side measurement and everybody knows what is a three-side figure. Yes, you're right. That is nothing but triangle. So are we going to discuss about triangles in this chapter? Yes, we are going to discuss about triangles in this chapter. So is it only triangles in this chapter? No, of course not. It is much more than triangles in this chapter. So more specifically speaking, we are going to discuss about right angle triangles in this chapter majorly. So for example, consider a right angle triangle that is A, B, C. So everybody knows what is right angle here, that is angle B. And what is the hypotenuse here? AC. Yeah, of course, that is AC because it is the opposite side to the right angle. Now, if I ask you, what is the perpendicular and base of this triangle? Many of you will directly say BC is the base and AB is the perpendicular. But you're mistaken here. Most of the times, this is the common mistakes which students perform. And what do we actually mean here? Anytime perpendicular or base is taken with the respect of the angle which we are taking. For example, in this case, if I take angle C, then what is the perpendicular and base of with respect to this angle? That is, the perpendicular is nothing but the opposite side of the taken angle, and the base is nothing but the adjacent side with respect to this angle. That is, base becomes BC and perpendicular becomes AB. But now consider a similar right angle triangle, that is PQR, and I have considered angle P here. So accordingly, we always know that hypotenuse is PR, opposite to the right angle. But if we consider angle P, what is the perpendicular here? That is, perpendicular is nothing but the opposite side to the taken angle, that is QR. So in this case, QR becomes the perpendicular while the adjacent side, that is PQ, becomes the base. So one major point which we learn from here is the base is nothing but the adjacent side to the taken angle, while perpendicular is nothing but the opposite side to the considered angle. Okay, so now talking about a few basic concepts of previous chapters that you will be using in this chapter. One is the angle sum property. Now, what does this angle sum property actually does? So it suggests that sum of the three angles of a triangle is equals to 180 degrees. That is, angle P plus angle Q plus angle R should be equals to 180 degrees. The other concept which we will be using in this chapter is Pythagoras theorem, which we have been studying from our childhood classes. Now, what is this Pythagoras theorem? So, Pythagoras theorem states that hypotenuse square will be equals to perpendicular square plus base square in a right angle triangle. Now, where will be using Pythagoras theorem? Suppose you are given with a question where you have two sides and you need to find the third side, majorly in right angle triangles. So you will be definitely using Pythagoras theorem then. Okay everyone, so now let's talk about trigonometric ratios. Before starting trigonometric ratios, what are ratios? Ratios are nothing but terms which can be represented in P by Q form. That is, for example, 2 by 3, 4 by 7 or 22 by 7 and so on. So these are basic ratios which we have already learned in our childhood classes. Now, for example, you take the right angle triangle PQR, and I have considered R as my angle. So with respect to this angle, of course, this is the hypotenuse of the triangle. Now, with respect to angle R, this becomes the perpendicular and QR becomes the base. So now what are the possible ratios which we can take by considering these three sides, that are hypotenuse, perpendicular and base? So we can come up with six different ratios, that are perpendicular by hypotenuse, base by hypotenuse and perpendicular by base. Now if we reverse this, we can write them as hypotenuse by perpendicular. This can be hypotenuse by base, and this becomes base by perpendicular. Okay, now let me just take this angle R as named as theta. So I called angle R as theta. Now to represent these ratios, we have a few names or a nomenclature that we represent perpendicular by hypotenuse as sine of the angle which we have considered, that is in case sine of theta. So P by H becomes sine of theta. So one major point that should be noted is I am not multiplying sine into theta. Sine is not a value, it is just a name which we have given to the ratio, that is perpendicular by hypotenuse. Okay, so perpendicular by hypotenuse can be written as sine of the angle which we are considering. Similarly, base by hypotenuse becomes cos of theta, and perpendicular by base becomes tan of theta. Similarly, hypotenuse by perpendicular becomes cosecant of theta, and hypotenuse by base becomes secant of theta, while base by perpendicular becomes cot of theta. So these are the basic terminologies or the trigonometric ratios which we use in this chapter. Now, if you will notice clearly, these two functions, that are sine and cosecant, while cos and secant and tan are cot, tan and cot, these are inverse to each other. That is, P by H here becomes H by P here. So what can we conclude from this? That sine of theta is equals to 1 by cosecant of theta. Similarly, cos of theta is nothing but 1 by secant of theta, while tan of theta is nothing but 1 by cot of theta. That is, sine function is inverse to the cosecant function, cos function is inverse to the secant function, and tan function is inverse to the cot function. So these are the basic trigonometric ratios that we will be using in this chapter majorly. Okay, so before moving to the new concept, we have few things to discuss. That is, I have already mentioned sine of theta is not equals to sine into theta. That is, this is pronounced as sine of angle theta. That is angle theta, sine of angle theta, and not sine into theta. That means sine of a plus b is not sine a plus sine b. That is, you cannot directly multiply sine into a plus sine into b. That is incorrect here. For example, if I have a question like sine of 70 plus 10, so this will become sine of 80 and not sine of 70 plus sine of 10. So this is the first point, that this is referred as sine of theta, that is sine of angle theta, not as sine into theta. Now coming to the second point, that is, in trigonometry, sine square theta is also referred as or equal to sine theta square. Okay, so we can directly write sine theta square as also sine square theta, and this applies to each and every trigonometric ratio. That is, cos square theta, tan cube theta, and so on. Okay, now moving on, we have already discussed that these trigonometric ratios are nothing but we have taken the ratios of two sides of a right angle triangle. That is, for example, if there is a triangle ABC and considering angle C as theta, sine theta here becomes perpendicular by hypotenuse, that is AB by AC here. So now we can understand one thing, that value of theta can vary, and it can vary from angle 0, that is angle 0 degrees, to angle 90 degrees. That is, theta can have values like 0, 1, 2, 3, and so on up to 90 degrees. It also has further values, but for now we just need to discuss from 0 to 90 degrees. So there are few standard degrees which we have taken, and we have values for those standard degrees, and we will be using such standard degrees to solve questions in our chapter. So what are those standard angles? Those are specifically 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So these are the five angles whose values are known to us, or we are taught in this chapter, and we need to be using these values to solve the questions which we will be getting in our exercises. So now let us discuss about the values of these angles at various trigonometric ratios. Okay, so now let's learn the values of these trigonometric ratios at various standard angles, starting with the angle 0. So sine of 0 has a value of 0, and sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 has a value of root 3 by 2, and sine 90 can be written as 1. So now cos function is nothing but the contrast of sine, that is, it comes in an opposite direction, that is, it starts 0 from here, and similarly cos 60 is 1 by 2, cos 45 is 1 by root 2 itself, cos 30 is root 3 by 2, and cos 0 is nothing but 1. Okay, and now tan function, as we know, tan function is nothing but sine theta by cos theta. So this becomes 0, 1 by root 3, 1 root 3, and as we are dividing it by 0, that is 1 by 0, this becomes infinity or not defined. Okay, so now as we know the three trigonometric ratios, the other three becomes pretty much easier, as we know that cosecant function is nothing but the inverse of sine function. Now when we take inverse of 0, this becomes infinity or not defined. Cosecant 30 becomes 2, cosecant 45 root 2, cosecant 60 as 2 by root 3, and cosecant 90 as 1. Similarly, secant function is the inverse of cos function. So this becomes 1, 2 by root 3, root 2, 2, and this becomes not defined again. And now talking about the cot function, this is the inverse of tan function. So here it becomes not defined. Cot of 30 is root 3, cot 45 is 1, cot 60 is 1 by root 3, and cot 90 becomes 0. Okay, and now we have the most important topic of this chapter, that is nothing but trigonometric identities. And these are just three formulas which you need to be remembering so to solve your questions which are in your exercises. So what are those formulas? The first one being sine square theta plus cos square theta is equals to 1. The second one being secant square theta minus tan square theta will also be 1. And the third one, cosecant square theta minus cot square theta should be equals to, yes, you have guessed it right, that is equals to 1. So these are the three basic and very important formulas that you need to be revising it or remembering it very well so that you can further solve your questions in the exercises. And that is everything for this chapter, guys. We have studied what is trigonometry, why it is used. We have studied few basic rules, trigonometric ratios, and then trigonometric ratios values at different standard angles, and lastly trigonometric identities. So I hope you find this video useful. See you in the coming ones.